Okay, I want to look at an example where the signs are different. This does add a few more options oftentimes. So I'm going to look at a couple more on here and then we'll jump to the guided notes and do those examples. Again, we're looking at our trinomials here. So let's say we have 2x squared minus 5x minus 7. And notice we always again ask ourselves, is there a greatest common factor? In this case, there's not, so we'll stop there. And if we look for factors again, as we go through this, right, 2x and x would give us that 2x squared. That's the only thing that would give us 2x squared. And then we look at our last times last, and that would have to be a 1 and a 7. But notice that this is a negative 7. So if that's a negative 7, then one of the factors has to be negative, right? So it's either like 1 times negative 7, or it's negative 1 times a positive 7. So we have to kind of consider those options. So let's look at what options we have. And again, we'll get to a point where we don't write out every option. But I just want you to kind of see that there are many different options as we're combining these that we need to train our brains to think through. So first of all, right, if we list this, we know that we're going to have 2x and x, and we know that there's a couple options, right? So we're going to say 2x and x. And then think about kind of the options that we could have. So first of all, I could have plus 1 minus 7, right? Or those signs could switch. It could be the negative 1 and the positive 7. And then notice I could put the 7 in the same parentheses as the 2x. So maybe instead I have plus 7 minus 1 or negative 7 plus 1. Depending on where those positives and negatives are, it contributes to providing more options that we're considering. So again, all of those work for our first times first and last times last. We just have to check the outside and the inside. So notice the outside here would give me negative 14x. The inside here, 1 times x, would give me a positive 1x. If I were to combine negative 14x plus 1x, I get negative 13x. That does not match the negative 5x that I'm looking for, so I go to the next one. 2x times a positive 7 on the outside is a positive 14x, and on the inside, that's going to give me a negative 1x. If we combine 14x with a negative 1x, we end up with positive 13x. Again, not what we're looking for. If we then look at the next option, so 2x times negative 1, that gives us negative 2x. And on the inside, we get 7 times x. And so that gives us 7x. And if we do negative 2x plus 7x, we end up getting positive 5x. So we're super close on that one. This is a negative 5x, so we can conclude that it would just be flipping the signs. Here again, outside is going to give us 2x. Inside will give us negative 7x. And that result with the 2x minus 7x will give us that negative 5x. So we know that our concluding or correct factor would be 2x minus 7 times x plus 1. Now, there's lots of different ways to do this, and this is just backwards foiling. If we can train our brains to backwards foil, then we don't have to use other algebraic methods. There are plenty of other algebraic methods, and if you're really, really struggling with this, I can send you a video related to one of those. But again, I don't generally list out all the options. I'm going to show you kind of what mine would look like if I was doing this exact same example, 2x squared minus 5x minus 7. When I'm identifying these, I do list out like 2x and x. Those are the options for the first part. And then the last part is 1 and 7. And then I just start to match them. So again, I know that one of the first pieces has to multiply by one of the last pieces, and then the other piece multiplies by the other piece. So I just test them this way. I'm going to multiply the different pieces, and I'm going to find which combination gives me a difference of negative 5. So that it works that way, right? Or negative 5x, I guess we could say. So notice here, if I combine this, right? This gives me x. This gives me 14x. Now, x and 14x, they do not have a difference of 5. So I actually just know that the x can't match with the 1 and the 2 with the 7. 14 is just too big. and subtracting 1 doesn't get me even close to 5. So instead of matching the x with the 1, I try the other two together. So this time I do the x times 7, which is 7x, and then I do the 2 times 1, which is 2x. Now in that case, right, we want a difference of negative 5x, so that means the 7x needs to be the negative, which means the 7 has to be the negative. So then when I put it into my parentheses, I just have to put it in correctly. The 2x, I want it to multiply by the 1, so those are like my outside times outside. And then the x, I want to multiply by my negative 7, so they become those inside terms when you're multiplying them. And then this would be your conclusion there. Okay, so I'm going to work through another one that's similar to that, and then I will do some of those on the guided notes. So let's just look at one more example. If we had something like, let's do one with the greatest common factor. So gotta think about one. Let's do 6x squared minus 28x plus 16. Let's hope this thing works. So we ask, is there a greatest common factor? If you look at these ones, they're all divisible by 2. So yes, right, we're going to have a greatest common factor of 2. So the first thing we'll do is we'll pull that 2 out. We get 3x squared minus 14x plus 8. Again, that a value is equal to 3, so we can't just split that up too nicely. We got to check some options. Now the 2 is just going to come with us, so whatever option we choose, when we get done factoring, that 2 is just going to stay there. So we're just looking at the trinomial on the inside. Now the only thing that works to get to 3x squared is 3x and x. And our options for last times last would be like 1 times 8 or 2 times 4. And then I look at this sign right here, and this is positive 8. So I know they're going to have the same sign. They're both going to be negatives, right? So we're just going to see if we can combine this. So again, I know those are both going to be negatives. If you want to write negatives here, you could just make everything negative. And then we're going to check our combinations. So again, I'm just going to try these two pieces together, one from the first and one from the second. That would give me negative 1x. And if I look at this, notice that's going to give me negative 24x. So negative 24 plus negative 1 is negative 25. That does not give me the 14 that I want in the middle. So I can switch it up and try again. Let's put the x with the negative 8 and the 3 with the 1. So that gives me negative 8x and negative 3x, which if I add those gives me negative 11x. So I know that this guy doesn't work. The negative 1 and negative 8, no matter how I combine it, is not working. So we try here, and we do like x times negative 2 is negative 2x. 3x times negative 4 is negative 12x. Notice there, if I combine those two, negative 2x and negative 12x, that works. That gives me that negative 14. So again, as I put these in here, the 3x, I wanted it to multiply over to the negative 4, so they have to be on the outside together. Then the x is going to multiply by the negative 2, so they go on the inside together, and it would be done there. Again, I can check my work if I want to, and I could just say, okay, 3x squared, that's what I was looking for. I get a negative 12x, I get a negative 2x. That's perfect to give me that negative 14x. So kind of checking that always that it works, and then notice that negative 2 times negative 4 is that positive 8. So that would be our final factored piece. So lots of different examples we could do. Let's jump over into the guided notes really quickly. And again, these are just a bunch of examples. So it walks you through kind of the steps. Again, factor out the greatest common factor if there is one. So if we were factoring 3x squared minus 30x plus 63, and we factor out a 3, then we're going to be left with x squared minus 10x plus 21. Once you do that, in this case, notice that the a value is now 1. So this one's actually pretty simple, like the ones we did back or before in 2.5. So we just split up the x, right? We get x and x, and we look at the signs. That's a positive 21. So we know that the signs are the same, and they're both going to be negative. And so we just look at the factors, right, of 21, which are 21 and 1, 7 and 3, and we can go ahead and factor that out. Now there is a little typo once you take out the greatest common factor, we should be looking at this negative 10x when we're looking at that. So fix that typo. So essentially the next one is showing you that there's just way more options once we add an a value. So now when we're factoring 6x squared plus 19x plus 3, notice that 6x squared could break down into a 3x and 2x, or a 6x and x. And then we look at the factors of the 3 at the end, and that could be a 3 and a 1, right? Or a 1 and a 3. So there's just so many different ways to combine these, like we talked about. And it's showing you that we just have to check the middle and the outside. And then we look at to see if it gives us the correct middle term there, the 19x. And every time you check it, right, then we come over here and we say, does it work? Does it work? And we go until we find the one that does. Once it works, you're done. You don't have to check every option. That would be then your factored form. So let's look at some of these examples. 10x squared minus 6x minus 4. Notice there is a common factor there. They can all be divided by 2. So if we divide out a 2, we end up with 5x squared minus 3x minus 2. Factors of 5x squared. So if I was listing out factors of 5x squared, sorry about that, we only actually have 5x and 1x. So that's not bad. Factors of negative 2 would be like 1 and negative 2, right? Or negative 2 and 1. So those are the ones that we could look at there. So there's a couple different options here. Either we have that 5x plus 1 and 1x minus 2. That's an option. Or we have the negative 1. We just switch the signs. And I keep writing 1x because I just want you guys to see that's, right, 5 times 1. But you can just write x. So there's a couple options. And then if we use the next factors, it could be that it's 5x plus 2 if I switch that 2 and 1. And then x minus 1. Or 5x minus 2 and I get x plus 1. So those are, again, the options if we were listing them out. And then we could check the outside and inside. So here we would get negative 10x. We would get 1x. That gives me a negative 9x. Not exactly what I'm looking for. I'm looking for negative 3x. Again, I go to the next one. This gives me 10x. Minus 1x is equal to positive 9x. That doesn't work as well. So we go to the next one. 5x times negative 1 is negative 5x. And 2 times x is positive 2x. That gives me a negative 3x. Victory. We found it. So we don't even have to check that last one. We know that our factored form is 5x plus 2 and x minus 1. Okay. Again, let's do a couple more, again, without listing out all the options. Now, I apologize. This first one is not factorable unless this is a positive 3. So if you will change that to a plus 3, then we'll factor that one. Okay, so we're going through to factor. Again, the first thing we do is look for a greatest common factor. Nothing divides out of 2, 7, and 3. So, or nothing common. So we look at our options here. I'm going to zoom just a little bit. This would be like 2x and x to give us the first piece. Then we go to the end. That would be like 1 and 3. We need everything to be positive, right? Because all the signs are positive. So we are going to just combine them and see what we can do. So I'm going to check this one. X times 1 is just 1x. 2x times 3x is 6x. Excellent. That adds to that middle term of 7x. So I want my 2x and my 3 on the outside, and I want my x and my 1 in the middle, and we're done.